Good morning. I am Dinanath, faculty of Department of Electrical and Electronics Engineering Department. Today I am going to give you a lecture about the topic pneumatics, basics of pneumatics, actuators. These are the basics about the pneumatic system, actuator system, and the DCB system. These topics are the one of the very important topic of the content unit 5th in the subject industrial automations and control. So in this topic I will cover what is pneumatic system and their basics blocks of pneumatic system. What do you understand by actuators and different kind of actuators, their working I will cover, and at last I will cover the DCB system, that is directional control valve system. There are different types of DCBs, classifications, nomenclature, their symbols, that I will cover in this lecture. So first of all I am going to cover about the pneumatic system. What is pneumatic system? If we all knows there is a different source of energy, as I will say the source of energy, either they will conventional energy or non-conventional energy, renewable energy, non-renewable energy. Like in the examples, if we say the coal, burning of coal, they give the energy by the flow of wind. There is a energy, that is the mechanical to electrical conversion energy. There is a solar energy, there is a hydroelectric energy. So there is a different of form of energy we can use in a further purpose. So likewise this is pneumatic, where in the case of pneumatic their source is air. So with the help of air we can transform the energy, conversion of energy is possible with the help of air, that is the term pneumatic energy. So in the case of pneumatic system we can use the compressed air. We cannot use directly air, we can use the air to transform of energy or conversion of energy, but instead of that we can compress that energy, that is in a surrounded, there is a natural air will be always present. So with this natural air we compressed it with the help of compressor and transmit it either in the form of force or in the form of energy. So what are their component or basics blocks to use the pneumatic system? That is with the help of normal air which is always available in an atmosphere. There is we can use the compressor block, so compress the air. So this is the with the help of compressor we can compress the air. Here we can use the reservoir, there we can use or reserve the air, compressed air. So these are the storage system kind of system. There is a control valve. What is control valve? That I have discussed in a lecture, that is the DCB valve, that is directional control valve to what amount of air we can move in which directions. That can things we can control with the help of control valve. And at last you can see this is the actuator. That actuators point will be also covered in this lecture. That is the actuators for what kind of mechanical work we want, that will be dependent upon the requirement to requirement, that can be fulfilled with the help of actuators. So these you can see the general layout of the pneumatic system which I have discussed in the this slide, that is the operations of the pneumatic system that can be flows through this basic block. So you can see the air from the atmosphere will be taken out, and before it given to the air compressor we can do the filtering kind of thing. So with the help of filtering we can remove the dirty particle which is coming in the compressor. That kind of different stages of the filter is necessary to filter out the pure air which is going into the air compressor. So you can see the air compressors are operated by the some kind of motors. So this kind of motor is required in the power supply. through the power supply, motors are operated. Motors, with the help of motors, the compressed air will be moved in the compressor. So this is the air cooler. Why we need air cooler? There is a compressor. With the help of compressor, we compress the air. Then with the help of air cooler, we feed the air, that is they they may contain their heat will be higher while doing the compressor, air compressor. With the help of air cooler, we reduce the heat, and that operations can be do through the air cooler. Now the next step is to store the water. Store the air. The air storage can be do with the help of storage reservoir. We can store the air as per as the requirement. If it is required, then there is with the help of either reservoirs is going to the further process, or otherwise the system will be stopped. Then the continuously there is a monitoring or a storing of air is requirement, that can be operations with the help of pressure switch. So now after air reservoir, it comes to the directional control valve, that is known as DCV block. You can see this is the 3 point of operations, or some cases there is a multiple point like 1, 2, 3. 1 stand for off, means it is not requirement to the actuators. In the second stage, if we switches to the second stage, that means we can raise the directions, flow and be increased with this valve. And if it is 3 positions, the speed of directional valve should be reduced. And there is a air actuators. The air actuators is used to the actuations. What kind of mechanical work is to be performed, either from these directions, this can be decided by the DCB block. The actuations, what kind of load will be connected with this. The air actuations can be moved from A to B, or they can be moved from B to B. So that kind of movement can be controlled with the help of pneumatic system. So there is a large kind of operations, based upon operations this air where we use. So where we use, that I have discussed in this lecture, where we use this pneumatic system. So basically this pneumatic system can be used to any kind of movement. Either if we say the requirement is linear motion, that can be movement can be do through the pneumatic system. If we want to square rotation, that can be operations can be do through the pneumatic system. If the requirement is to rotary motions, then can be also we can do with this air. So this is very important. Flow of air, that is the compressed air, can be moved in either kind of directions according the operations can be operate. That can be used daily to daily use purpose. So pneumatic system can be used in a daily to daily use system, or either or mostly we can use in a industrial purpose work. Like if we say where we use the daily to daily use work, like we can imagine in a dental drill or in a dental clinic. We will find a dental clinic where they use the pneumatic force during the checkup and cleaning of air, where pipe organs and peons, that is the compressed air, to produce the wonderful musics. So these are the two operations, that is the operations for the music, or either for the cleaning of dental teeth. We can use a pneumatic system that can be used in a daily to daily use purpose. Or if we, but the pneumatic system, they required very higher forces. So mostly we will find the applications on the industrial purpose, where we use like in a manufacturing industries. So we will find in where we use manufacturing industries like an automotive industry, machine tool manufacturers, and domestic and commercial appliances manufacturing system. We will find the multiple operations of the pneumatic system. Another one is processing industries like chemical factory, food processing factory, textile industries, paper industries. They need the pneumatic system. Either we can use in generally a brake system in any automobile, they can used in a railway coaches, wagons, printing presses. They will find the wide applications of pneumatic system, as well as, and the most use of the today use on the pneumatic system or waste use of pneumatic system, you will find in the industrial robots, where the objects can be picked up from one place to another place, or we can move very heavy objects from one place to another place, or the replacing the system, we can use the pneumatic system. So these are the use of the pneumatic system. Other industrial work you will find in a filling industries, packing industry, a stamping industry, drilling industry, hosting industry, punching industry, clamping, assembly system, riveting system. These are the various or wide applications of the pneumatic system. So before going to the brief functional block of pneumatic system, first of all they will work, I will discuss some laws which is based upon that this pneumatic system work. So the role of Wahl's law is very important with respect to the operations of this. They are given with respect to gases applications. This is dependent upon the pressure and volume, how the pressure and volumes are correlated. So we will find with this graph, we will according to Boyle's law, pressure is inversely proportional to volume. So if the pressure is increased, if volume is decreased, or in other ways the pressure is decreased when volume is decreased. So you will find with this representation of the respect of volume and the respect of pressure. And important thing is noticed in this Boyle's law, it is working with the absolute temperature, or you can say temperature is temperature of the gas is kept constant. So another law is very important with related to the pneumatic system, that is Charles law. The Charles law is referred with respect to volume and temperature. So we will find this graphical representation of volume and temperature. You will find volume is directly proportional to temperature. So if we increase the volume, temperature will increase. If the decrease the volume, temperature will decrease. So these are the direct correlations with respect to volume and temperature, that is known as Charles law. In this respect, pressure is constant, there is no change in pressure we can imagine, and this is assumed to be contactless, there will be no leakage with that. With these considerations, their Charles laws are given. So with this law, the most important functions or part of the pneumatic system, that is known as compressor system. So what is compressor? So it is a mechanical device which convert the mechanical energy into the fluid energy. So fluid may be anything, that may be air, or they may be liquid. So in the pneumatic system, we having only discussed about the pneumatic system, that is air. So the compressor which increase the air pressure by reducing its volume, as discussed in this laws, that is Boyle's law and Charles law. With respect to that volume which also increase the temperature of the gas, temperature of the compressed gas, that is Boyle's law. So, the compressor are classified based upon the two taps, that is the based upon the tap operations, they are classified two tap, that is positive displacement compressor and another one is known as dynamic displacement compressor. So, this is one valve or one cylinder operation, that is piston compressor. You will find this is the piston arrangement we will find in the internal combustion engine, that is in IC engine, either we talk about 2-stroke engine or either we talk about 4-stroke engine configurations. This is the role of spring is very important and the movement of with respect of pistons is there. So, there is a air inlet, there is a operations when air is inlet into the system, that is single cylinder system. As air is input inside to the cylinder, this pistons will be moved down according to the crankshaft will be moving down. So, as this move in the piston is moved on the downward directions, as it come to the downward side, that is the bottom dead center, the again with the help of spring they move in a upward direction. So, in this case the air is compressed. As air is compressed, the temperature inside the chamber will increase and the combustion take place. After the combusting, the last stage, the compressed air, that is the heated air is coming out from the outlet block. So, there is a in piston compressor there is a one inlet block and one outlet block, and it need to the one cylinder arrangement. So, in this case they can use for the very low application at around 20 atmosphere pressure can be used with this piston arrangement, and the medium or lower applications we can use this piston compressor. Another one is double acting compressor, somewhat higher if in sub application need higher pressures, on that case we can use the double acting compressors. Here there is a two valve, one for input, one for output, as well as the movement in both the directions can be done with the help of double acting cylinder. And in this case the movement, likewise in a previous case, that is in a case of piston we will find the spring applications, but in this case of double acting compressor we doesn't need the spring, automatically they are moving around based upon the movement of the air. Now, the multi-stage compressor, this is used the very large applications where we need high amount of pressure, where we use multi-stage compressor. These are the same, there is a two valve, one is this and this is the second stage, high pressures and the lowest low pressures on this side are pistons arrangements are used, other things are same. Only with this limitations of multi-stage compressor is that the heat will be generated will be very high. So, for the removing of it we will use the in between the low pressure and high pressure we use the intercooler, so that the temperature will be reduced, but it can be used for the higher pressures. Now, come to the another topic, that is the actuator. What is actuator? So, after compressor here or pneumatic system where we use. So, actuators can be moved based upon the converted energy, that is the either may be compressed air or the or the pneumatic high pressures of water. So, this convert energy into the pressurized hydraulic oil or compressed air. This is with the part of hydraulic oil means there is the hydraulic pressures will be used, that is the hydraulic energy will use, and if we talk about the compressed air means pneumatic system will be used. So, based upon their the pressure, their energy, they can be they are the responsible the movement of actions of motions. So based upon the movement of action, the actuators are classified into the three types, or you can broadly classified the two type. I will discuss what is three type, but broadly classified it is two type, that is the linear actuators. So it device that convert hydraulic or pneumatic into the linear motions, where the linear motions will be required. Another one is rotary actuators. In this case, the hydraulic or pneumatic energy is converted into the rotary motions. So that case actuators are used. So these are the source of energy. Source of energy can be hydraulic or pneumatic system. We have to put the control system, that is the arrangement how the actuators will be performed. So based upon their control system and based upon their source of energy, the movement of the motions will be performed. Either the movement based upon the movement of motions, they can be rotary motions, and that can be linear actuations motions can be provided. So if we go to classifications of actuator, so they are actuators are classified based upon the two types, that is either based upon the motion and based upon the source of energy. So based upon the motion, either they are the linear actuator or they are the rotary actuators, that is the actuations work. If we talk about the source of energy, like pneumatic system, like air, what I have discussed in this lecture, or the source of energy may be hydraulic system, that is water or oil, or electrical actuator like a motor or servo system, and these are the actuations work. So this is actuations based upon the different cylinder, that is either they are single acting cylinder. You can see in this case single acting cylinder, this is the path, or you can say the valve for the motions of this piston. This is piston is spring connected. So as per the air or compressed air or the oil or any fluid is given to the system, there is a movement, that is the positions will be changed according the actuations work will be performed. In a double acting cylinder, with respect to one valve, in this case we put two valve. So with this valve, one is for the input of the source and another one is exit of the source, or somewhere use this is the input of the source and this way the exit of the source. So when based upon the input and output, their actuations work will be performed, that is the movement, linear motions. This both single acting cylinder which I have discussed here and a previous one, that is the single acting cylinder, both are responsible or requirement for the linear motions. Another rotary motions, the example of rotary motions is best applications for the gear motor. You can find the fluid is at low pressure, the fluid may be air or oil, is given to this chamber. This is the gear arrangement, these two are the gear arrangement. So as we fluid is given to the system from this valve, the pressure is equally distributed on both of the end. Based upon that, the one of the gear is moving this directions and another one is moving in the another direction. This kind of arrangement is considered or taken in this arrangement. Based upon that, the movement of gear, there is some shaft is connected with this and the actuations work will be connected, and some fluid will be at high pressure is coming out from the gear motion. So this is used or responsible for the rotary kind of motions we can perform. Now at last I will discuss in this lecture which is very important, that is DCB system, or it is widely known as the D stand for directional, C stand for control, V stand for valve, that is known as directional control valve. We will find various applications in various kind of industry. They are used different kind of DCB system. What is DCB system? Where we use? So directional control valve, this is allow the fluid or in a hydraulic system or in a gases in the pneumatic system to flow into the different path, that is movement of different path with the help of different valve arrangement, different ports arrangement, which is used to provide a passaway for the flow or from the component to the components or sources. So there is use for the flow of gases or flow of air or fluid in a different valve for the different actuations kind of work, but they can be controlled or they can be provide the directions, and that's why they are known as directional control valve. So there is a different directional controls valves are available. I will discuss firstly very basics of DCB system, that is known as 2x2 DCB. 2x2 DCB. What stand by 2x2 DCB? First 2 is represented for valve, and second 2 responsible for positions. So if it is 3x2 valve DCB, means there is a 3 valve and 2 stand for there is a movement of positions, there will be 2, either there were 5x2, 5x3, 3x2. So these are the different configurations of DCB arrangement are possible. So this is 5x2 stand for, means there are being 5 valve, means there is a 5 positions to enter the source. The source may be air or source may be fluid. 2 stand for they can move in a 2 directions, 2 positions. This 3 stand for they can move in a 3 positions. 5 stand for 5 valve. This 3 stand for 3 positions, 3 valve position. The flow of air can be entered in a system by the 3-way, and these 2, that is they can take 2 positions by the movement of this cylinder. So you can see 2x2, this valve has 2 port, that is the first 2, and another one is the 2 positions, that is this 2. So 2 ports are inlet port and outlet port is represented as B. With these conditions, you can see in these conditions there is a valve will be closed with this cylinder. So there is a no movement of path is possible. So in this open spring, in this positions from either the flow will be moving from A to B, the movement will be not done because the valve positions will be closed. But if there is this piston, this is work like a push button. If the push button is pressed, the spring is compressed. As spring is compressed, the movement of air or fluid is possible from A to B position. These are the symbolic representation of this DCB. This is the spring movement, that is the spring can be moved in either directions, and this arrow is represent the movement from A to B. So initially this is the close, that is normally closed positions. As we press the switch like a push button, their movement of air or fluid can be flow from A to B. Now this is the configuration for linear motions. This is the rotary spools type 2x2 DCB positions. So if we want to linear positions can be moved in a linearly. If we want to rotary movement by this spool arrangement can be done by the rotary spool position. They are having two inlet port, that is input inlet A and inlet B, outlet B. This both are closed, like in this condition. In these configurations the springs are used, but in this case springs are not used, the spools are in these positions, means the flow of air or any fluid, it is not possible from this position to these positions, because this valve, that is the port, have been closed. But now what happened, if the spools are moving towards the 90-degree, either in case of clockwise or either they move in anti-clockwise directions, this is the inlet port A, let us suppose this is inlet port A, this is the inlet outlet port B. So you will find the path is open. As the path is open, as the spool is moved in directions, that is, this is 90-degree, sorry, this is 90-degree, they can move, a flow of air or flow of fluid can be moved from A to B, or either in case of B to A. This is possible. This is any rotary actuations, because their further the connections or arrangement will be as like that, so can move in a rotary direction. So we will find that in the first position of the spool, the ports are closed, working fluid cannot flow from port A to port B for this configurations. But after spools is moving or rotated through the 90-degree, either in clockwise or you can see anti-clockwise, in any directions, it opens the passage. They will find the passage. As they get the passage, the port A to port B, and hence working fluid flows from port A to port B. That is the movement of as positions is open, the movement of air or fluid is possible. According the rotary actuations will be done. Now come to 3/2 direction control valve. Thus there is a same arrangement. They having 3 port, that is A, P, T. P is stand for port 1, is something actuation, and this T stand for tank. Their movement initially their movement will be possible from P to A, but this tank will be closed. But as this is initially the push button will be pressed, but as the release the press button, their movement P to A will be closed. P to A movement will be closed, but as they are open, the movement is possible from A to T, their A port A to tank T, which is not possible in the previous case. And what stand for 3/2 direction DCB valve? 3 stand for 3 port. You will find port 1, port 2, port 2, 3 port, and they can move in 2 directions, 2 positions like this and this. So this is known as 3/2 directional control valve. So these are the different configurations, port and positions configurations. You will find 2/2 directional valve means they are being 2 port and 2 position. Similarly 3/2 there is a 3 position. So this is 3/2 directional control valve. Similarly 3/2 directional control valve normally open. This is 4/2 directional control valve. Means they are being 4 positions, 4 port and 2 positions is possible. You can see simply for the understanding point of view, first 2 is for position and 2 stand for the movement. So if it is 3, if it is this is 3 or this is 2. So we will find in a case of 2 there is a 2 square block. If it is 3 means you will find 3 square block means 3 valve position can be possible. So these are the different valve and positions arrangement. Through that we can use different applications in a pneumatic system, as well as same arrangement can be used in a hydraulic system as well. I hope you will get this topic, that is pneumatic system and actuators, and these are the different DCV system. With that, thank you for that this lecture. Okay.